Guys, I'm Kumar K, your favorite teacher for DSA plus OA plus CP. So recently, Microsoft has been asking very hard problems, DSA problems on graphs and trees in their online assessments, and all the problems are hard and unseen in nature, and the students are facing lots of difficulties in that. So, in this particular video, we are going to solve the recently asked Microsoft SD2, which is the engineering role online assessment problem. Okay, so let's go to the video. But yeah, one thing which I want to tell you people is that the video can be a little longer and there can be many prerequisites which you need to know. So all of them are given in the description. Make sure you go through them, understand them, and the video can be long, but watch it fully if you want to master the DSA skills till the FANG MOA and interview level. See you all in the video. Ram Ram. So hello guys, with the name of God, Ram Ram. This is a very daunting and dangerous tree problem asked in Microsoft SD2 online assessment. Okay, Microsoft can pay you a total CTC of anywhere from 50 lakhs to 85 lakhs for their SD2 engineering role. Okay, so generally in the online assessments, they will give you such large paragraphs and such large diagrams, and this will be a very hard unseen DSA problem. You will have to analyze it and you will have to find its solution yourself. It will be a totally new problem for you. So students keep on asking me that, sir, please help us, sir. We are failing the online assessments. Many people from my LinkedIn and YouTube community keep on asking me these things. See, you can only pass the online assessment. See, I've written here clearly. To crack the online assessments of the top tech companies, only if you pass the coding online assessment, only then you will get the interview there, right? You can pass the interview only if you practice hard unseen DSA problems in a structured manner regularly. Okay, do not just depend on the standard influencer DSA sheets, and nor do just stop at 200, 500 easy medium LCGFG problems. You need to go far and you need to do lots of contest training as well apart from hard and seen OA problems. Both of them you should be doing. OA training also, CP training also. Now, if you are someone who is watching this video, you should attempt to do the best warm up DSA plus OA plus CP course in the country created by me. It will take only 5 to 10 days, but complete this course. Specifically, the tree part of this you should be knowing, or else, whatever I'm explaining in this video, you will not understand. So, please go through all the tree videos, okay? Because the second video in the warm up, best warm up DSA plus OA plus CP course in the country, if I take the second video from the tree course here, like I try to go here, this is also one of the prerequisites for this problem. Okay, so like you should be knowing this as well, whatever has been taught here. Okay, in this I have taught a very special kind of bottom up traversal DFS. Okay, see, when we talk about trees in online assessments, now they are going to give you general trees, they are not going to give you binary trees. So bottom up traversal DFS plus DP is a very nice OA plus CP trick. You might not be knowing it, but now you know. Go through the course, go through the videos, understand it nicely. So these things are clear to you. Obviously, because I give OA plus CP training in my program and constant job referrals, you guys can see that my student has recently cracked SD internship offer from Microsoft, and multiple students have cracked even full-time 51 LPA off-campus SD offer from Microsoft. All of them were off campus. My students love to crack Microsoft off campus, by the way. So these things you can see and observe. Now, if I try to read the problem, our tasks concern a city with n roads connecting n plus 1 junctions from 0 to n. Roads are connected in such a way, there are some houses, there are some offices. From each, all the citizens work in the office and use a car to travel from their houses. Each car has 5 seats and consumes 1 liter of fuel to move from one junction to a neighboring junction. The citizens want to set up a carpool scheme that allows them to travel to the office in a way that minimizes the total consumption of the fuel. People can change cars at each house and then continue to travel together, calculate the fuel consumption, see how difficult it is. Do you think if you just do one, two liner DSA problems, you are going to solve this? No, you need special focus and attention. Let me even make this document bigger for you. So yeah, so telling you the truth, please do the things properly as much as you can. Now I will make the understanding little easy for you. You can go through those large English paragraphs. I can just tell you some simple things. Tree is given to us with the nodes whose labeling is from 0 to n. So in this question, understanding the question is the most important part. So your English comprehension skills should be just top notch and very good. Tree is given to us and the nodes are numbered from 0 to n. Okay, this thing I think is clear to you. So we do have how many nodes? We have n plus 1 nodes. What is a tree? You need to watch the prerequisite video, you'll understand. N plus 1 nodes and n edges are there. Exists in the tree. At each node, at each node, there exists one person. At each node there exists one person and one car. Person at that node can travel to any adjacent node in that car or some other car which has reached it. When a car goes from node X to node Y, it costs 1 liter. Okay, so make sure all the people reach node 0 in minimum fuel. So basically guys, in minimum number of liters, using all the cars and and the people who are in the car, you need to make sure all of them reach to node 0. Now this was not that clearly written here, but I have made it easy for you. So let's go through some test cases, right? So 0, 1, 2, 3. Okay, 0, this is the tree, right? 0, and this is 1, and this is 2, and this is 3. So now what are we supposed to do? There is a person here also, and there is a person here also, there is a person here also, and there is a person and the node number 0 also. All the people want to reach node number 0, means P1 also wants to go to node number 0, P2 also wants to go to node number 0, and P3 also wants to go to node number 0. Hopefully these things are clear to you people, and you face no problem in the understanding of these concepts. Okay, P1, P2, P3 all want to go towards node 0 only. All just are deeply in love with node 0. So what can P1 do to reach node 0? He can use his car C1 and travel here, right? So the person standing here will use his car. At each node the person has his car also. So they will use the car 1 and they will travel to node 0, and it costed them 1 liter of fuel. P2, he will use his car C2 and he will travel to node 0 up, right? It costed him 1 liter of fuel. P3, it will use the P3 person will use his car C3 and go to node 0. It will cost him 1 liter fuel. So total fuel consumed is 3 liters, right? After 3 liters, the final in the finale at node number 0, P1, P2, P3, P4, all the people are at node 0. So basically, somehow all the people have to reach node 0. But the problem starts because, like, this is a simple test case. In some advanced test cases, what can happen is some people can afford to leave some cars in the middle and sit in other people cars. That makes everything complicated. Okay, it really makes it complicated. Clear? In the middle, sometimes it can happen that someone sits in some car and someone leaves some car. So these things can happen, you need to know. Okay, for example, I'll try to show you one more test case. This video can be long, but put your full attention and full focus. The future you will thank you for it. Like, let's go through this test case, right? 0, 7, 8. Okay, this will make it much more clear. 7, 8, both are connected to 0. Then node number 1, let's go through it. Node number 1, then 2, 3, 9, right? So node 2, node 3, node 9. Okay, yeah, this is clear. Like, where is our Microsoft document? Yeah, node 9 and then 564, right? After node 9, we get it here as 5, 6, and 4. Now listen up. Everyone wants to reach to node 0. Okay, there are so many people here. For P7 and P8, they will reach here in just 1 liter, right? 1 liter. P8, P7 will use the car C7, P8 will use the car C8, and they both will reach the node 0 in 1 liter. So total 1 plus 1, 2 liters. 2 liters are enough to make sure P7 and P8 reach the node 0. But what about the all the other nodes? See, I will not I will not try to directly take P1 to P0. That is not efficient. There is a better trick. Each car has 5 seats, right? So first I will try to make sure that P2 and P3 reaches node number 1. So P2 will reach the node number 1 in his car C2 in 1 liter of cost. P3 will reach node 1 in his or her car C3 in cost 1. So now you can assume that at node number 1 there are which people are there now? P1, comma P2, comma P3, and this phenomenon has happened by spending 2 liters. So 2 more liters we have spent. By spending 2 more liters, now at node number 1 we have person 1, person 2, person 3 all are standing there. Same concept you can use here, right? P5, P6, P4, all three of them can reach the node number 9. So at node number 9, now you have P9, P5, P4, P6. You can say it like P of 4, comma 5, comma 6, comma 9. So P4, P5, P6, P9, you have these guys standing at node number 9. And at node number 1, P1, P2, P3 are there. Okay. So guys, at node number 9, 4 people are standing now. At node number 9, 4 people are standing. Can these 4 people travel to node number 1? Yes, just by using a single car. What I'm trying to say, that this is node 1 and this is node 9, right? And on node number 9, P4, P5, P6, P9 are standing. And there are 4 cars also. C4, C5, C6, C9 cars are also there. All of them want to travel to node number 1. What is the minimum best way to do it? You can just do it using one car. Select any car from C4, C5, C6, C9. Let's say you take the car C5. In C5 car, there are 5 seats, right? C5 car is there here, right? You have all the 4 cars here because all have come here. But now you will only use C5 car. You don't need the other cars anymore. In C5 car, all these guys will now sit. So P4, P6, P9 will leave their cars and all of them are going to sit here. Because, and the car has 5 seats, right? Now the C5 car will go to node number 1. So all 4 of them have traveled in just 1 liter of cost. Because in one car, the 4 people could sit. So guys, P4, P5, P6, P9, all will reach node number 1 in just one cost. So 1 more liter has been spent. After doing all this technical jargon, finally, at node number 1, which guys are there? P1, P2, P3, P4, P5, P6, P9. How many people are there at node number 1? 1, 2, 3, 4, 5, 6, 7. 7 people are there at node number 1. And how much cost has been spent? 1, 2, 3, 4. 4 plus 3, 7. 8. 8 rupees have been spent already. At node number 1, now there are 7 people. At node number 1, there are 7 people now. Okay. P1, P2, P3, P4, P5, P6, P9. Okay. All of them need to reach node 0. So what is the best way? How? See, if so many guys have reached here, there must be, few cars also here like C1, C2, whatever. Some cars will be there, C5 car. Some cars will be there. You never need to worry if you have enough cars or not. Because if you do the mathematical analysis in this hard level OADSA problem,
You will come to know that there will always be enough cars because each node has one car and so many people are going up, right? So how many minimum cars are needed to make sure the 7 people can reach node 0? 7 people are there, right? One, two, three. Like, let me represent it like this. At node number 1, there are 7 people. One, two, three, four, five, six, 7. Let's say like this. First 5 of them can go in one car, and the last 2 of them can go in second car. So using the first car, these guys will go here, and using the second car, these guys will go here. So 1 liter here, 1 liter here. So 2 liters more. So 8 plus 2 to in total 10 liters you're able to do it. Wow, such a lovely problem. I just love it. So in total 8 plus 2, 10 liters, you can get the job done. Now how do we solve this problem? See, there is a special trick in OA and CP problems, okay? That special trick is that also you can join our Sept cohort as well for one-to-one mentoring, day live training, and job referrals. Recently, we have given many students the job referrals of Qualcomm, Microsoft, and many more like that. Analysis says that, guys, there is a simple trick in OA and CP. Whenever lots of, I know this by experience. Let's say this is a problem, okay? This is a problem. And let's say lots of simulation and movement is happening in the problem. Lots of simulation plus movement is happening in this problem, okay? So when on the tree or array lots of simulation movement is happening, what you can do is you can just focus on the total movement happening between the adjacent values of the array, or total movement happening between the edges of the tree. So in this question, guys, you can just focus on each edge of the tree and the problem will get solved. And the first thing which you should do is root the tree at node 0. Root the tree at node 0. Root the tree at node 0. Why? It makes dynamic programming on tree. It makes DP on tree possible, and the path for all other people, and no people all other people on other nodes is clear bottom to up. So guys, see, whatever tree is given to you, let's take a tree. Let's say this tree is given to you. Node 1 here, node 2, node 3, node 4, node 5, node 6, node 7, and node 8. What is the meaning of reroute it at node 0? So obviously, if you're watching this video, I assume you have done our tree course and the TP course. Okay, I have given the links of the prerequisite course. Do it, you will understand what I'm trying to teach you. This is advanced love Steve, baby. Let's cook, baby. Let's cook. Now listen, baby, listen to me. Ram Ram. Reroute means mold the tree in such a fashion such that zeroth node is at the topmost. So 0 will come here, and this one I will shift it down like this. I'm just changing the structure. Okay, like this. Now it's looking cool. Now it's looking fantastic, right? See? Okay. So now the procedure becomes very, very easy. Why? Now you know the clear path for all the other nodes except node 0. This guy also wants to go from bottom to up. This guy also wants to go from bottom to up. This guy also wants to go from bottom to up. This guy also wants to go from bottom to up, bottom to up, bottom to up, bottom to up, and bottom to up. So what is the most efficient, greedy, and dynamic programming strategy here? You should not directly try to make a phi go to 0. No, 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 no. First, you should take the load of 8 and put it at phi. Then 8 and phi should try to go above. This way, the minimum number of cards will be getting used. Okay. So, what you should do is the general logic in this whole simulation, just try to focus on each edge. Just try to focus on the total liters being spent on each edge in the optimal case. So guys, when will the optimal case happen? Optimal case happens when, first of all the leaf nodes at the bottom start pushing up, start pushing up, and this type of special process continues. So what do I mean by this? You guys can see na, which are the leaf nodes here. I will color them with let's say white color. This is a leaf node, this is a leaf node, the node which does not have any children. Okay, so first movement should always be from the leaf nodes only, because leaf nodes have no other option apart from going up. So first the actions should be taken on the leaf nodes like 1, 7, 3, 4, 8, and 6. Once you are done with the leaf nodes, then just check the nodes above the leaf node. So which are the nodes above the leaf node? The next node above the leaf nodes is 5. So then the turn will come of 5. At 5 you will start trying to do the pushing. Then the turn will come of 2. And now when 172 all the children of 0 are ready, then you can comes the turn of 0 execution. Okay, the node 0 execution. So this is called as the bottom up DPDFS traversal. You might not be knowing these tricks. That's why I'm asking you that stop doing standard DSA stuff for God's sake, and please watch the general tree videos of hard level DSA or CP from this course. Just 5 nice videos I made. You watch them, you'll understand what I'm trying to teach you today. The link to this is in the document and in the description. Okay. So now we need one more concept. Which concept? You need to know the size of the subtree. After the rerouting is done, you just need to know the size of the subtree. If you know the size of the subtree, the problem is solved. So dp of I will generally tell you, dp of I for a node will tell you the size of the subtree of node I. Basically, how many nodes are below node I, including node I. Okay. So this is node 1, this is node 2, this is node 3, this is node 4, this is node 5. Okay. So what is dp of 1? dp of 1 means how many nodes are there below node 1. So 1, 2, 3, 4, 5. So dp of 1 is 5. What is dp of 2? dp of 2 means how many nodes are there below node 2. There is no, only one node is there, right? One. What is dp of 3? How many nodes are there below 3 including node 3? dp of 4 is 1, right? Because including 4 below 4 there is only one node. dp of 3 including 3 and below 3 there are only 3 nodes. And dp of 5 including 5 and below 5 there is only one node, right? Okay, good, nice, awesome. So these things you understand, right? Now why are these things needed? Because these things directly solve the question for you. You will use a bottom up DPDFS traversal, which I have taught in my course. You are going to travel the tree from bottom to up, from bottom to up, and you are going to calculate the DP of each tree. Why? Because you will need it in the future. How? I'll explain that to you. Zero, like we can take the case, like the similar case which we discussed in the past year, right? Like 0, 1, 2, 3, 9, 5, 6, 4, right? 0, 1, 2, 3, 1, 2, 3. Just let me check if it's 0, 1. Okay, okay. 2, 3, 9, 6, 5, 4. 1, 2, 3, 9, 6, 5, 4. So what is the DP of 6 in our case should tell you, obviously DP of 6 will tell you that there is this one person is there, so one person wants to go up. So DP of 6 tells you what is the cost of the person at node 6 to go up. Okay. DP of 5 will tell you what? DP of 6 will tell you what? That one person wants to go up. DP of 5 will tell you that one person, or DP of 5 will again tell you one, right? One person wants to go up. DP of 4 will also tell you that only one person wants to go up. What will be DP of 9? Because you are sure when this, see, you are going from bottom to up, right? Bottom to up. You're going from bottom to up, right? So when I will be writing things like DP of 9, DP of 9 is 4. Do you understand the meaning of this? DP of 9 means if you combine all the elements below 9 and including 9, how many elements will be there? There will be 4 guys standing here. How many guys will be standing here? 4 guys will be standing here. Once the bottom to up procedure is done and all the nodes, all the people who are at the bottom have reached node number 9. What will be DP of 2 and DP of 3? So there is only one. So only one person wants to go up. Only one person wants to go up here. But what will be DP of 1? What will be DP of 1? DP of 1, how many people will be there standing at 1 who are trying to go to 0? 1, 2, 3, 4, 5, 6, 7. When this bottom to upward procedure is happening at node number 1, there would be 7 people standing. 7 people would be trying to go to node number 0. So that's it, guys. That solves the problem. Let's assume you have calculated DP of all the nodes. Now the final answer will be what? Final answer. See, this is such a big trick. Sum equal to sum plus DPI of phi. You will divide by phi, right? Because, for example, at node number 1, how many guys are there? 7 guys are there who want to go above to node 0. So what will be the cost to push all those guys to node 0? Can you think about it? Cost of that will be 7 divided by 5 plus 1. Because you can break it in the chunks of 5 only, na? So 7 by 5 rough division will be 5 1 5, 1 plus 1 2. So 2 cars will be needed to transport all these 7 people to node number 0. And this is the best way. Why? Because I have taken all the people in the minimum number of cars to the upwards node. Guys, I hope you can imagine that all the people from the lower nodes needs to slowly go to upward nodes, and all of them should join and just keep on going in minimum number of cars from bottom to up. I hope you can get this feeling in your head, in your mind, in your brain. We all have feelings for girls, crush, boys and things like that, but you need to develop the feelings for the problem. Okay, you would understand it much better if you did my prerequisite course. And if you are in my actual live training cohort, there are like 50 to 100 videos on this tree and tree dynamic programming and general trees, apart from the binary tree and BSC stuff, right? That's why my students are so successful. So you just need to calculate DP of everything and DP of I by phi. So why am I doing DP of I by phi? Okay, so I'll tell you one thing. If I directly scroll below, here DP of I will tell you what? Size of subtree rooted at node I. Okay, so now I will tell you one thing. If node V is parent and node U is child, then dp of u by phi indicates. I remember that Pushpa movie, they used to say the groups indicate for that redwood, right? Anyways, going back to the topic and should not get distracted. Guys, if node V is the parent and node U is the child, you can imagine na V and then niche uska U. So dpu of phi indicates that all the nodes which all the people standing at node U want to travel up to node V, and they will need minimum DPU by 5 cars, DPU by 5 cars, or you can say that much fuel to do it. So guys, if it at each node, if you calculate DPU by 5, let's say this is node I and this is node J. Okay, and there were many, things below. Let's say DP of J is, let's say, 15. Okay, it means total 15 guys are there. So all the 15 guys have come here and now they are standing here. All the 15 guys. You know that all of them have to go up, right? Because the node number 0 is at the root. So all have to go up. So for now, all from J, 15 people standing at J want to reach at I. What will you do? 15 by 5, 3 cars will be needed. How many cars will be needed? 3 cars. So this edge from J to I will be traveled by 3 cars in the optimal case, or you can say 3 liters. And those 3 cars will come here, guys. Okay. And if here it comes, and if it needs 4 cars in the future, if needed, one car of I will always be there to help it out. So you never need to worry if you have enough cars or not. You can do a little bit more mathematical analysis on it and you'll get it, baby. Because if you can take all these guys in 3 cars here, and only one guy is getting added extra, so at max you need 4 cars, and this guy also has its own car, na? So just chill, man. Just chill. Just chill. Now, that's it. So if I try to show you the code, like let's go to the code part quickly. Like this is the implementation. I did not have much time, so I just put here the C++ implementation, but you guys can go and check out the Java Python implementations as well. Okay. So let's cook, boys. Let's cook. You guys can see that I've taken the input A B and made the tree graph, and then I did my bottom up DFS where I calculated all the DP values. Okay, you can see them, DP node. Then guys, I travel everything and I do DPI by 5. I'm doing cell division because if there is a remainder, one extra car is needed. So DP plus n minus 1 by n will give you ceiling value, and that's it. So hopefully you guys loved it. Okay. And one more thing I had to show you is, just a second. Yeah, just a second. Yeah. So what I want is that you become very happy and successful in your life. So always keep working hard, and Ram Ram. Okay. All the best to my student also who got selected. Ram Ram.